Hello everybody, this is Advanced Geometry, starting chapter 6, which as you can see is about similarity. So we've been talking a lot about congruency where all the corresponding parts are all the same. Similarity is, well, they're not the same. They're similar, but they're not the same. I guess the basic idea of similarity is you're looking at a picture very much zoomed in, and then the other image is that same thing but zoomed out. So it's the same shape. One's just bigger than the other one, okay? In this section, we're talking about the basics of the idea of how similarity works, and that's ratios and proportions, and there's another idea called a geometric mean. So, a ratio, it is a way to compare two numbers, A and B. Most of the time, it's written in simplest form, and you should always be writing it in simplest form. But when you see a ratio of A to B, you can write it this way, or it can be written this way. But you notice how A was first, and then B. A goes in the numerator, or it goes first here. And then B, which second, goes in the denominator. So there's a connection to how it's stated, what you're comparing to what, and how it's written as a fraction. So, in this example, write the ratio of A to B. Now, we're not talking about areas here, it's just name of the first rectangle is A, the name of the second rectangle is B. So, if we look at these two rectangles and look at their heights from A to B, so I'm going to put the height of 20 over the height of B, which is 10, and put it in simplest form, that's 2 over 1. And again, you could write it as 2, 1. Now, with the widths, do the same idea, A to B. So we would have 9 over 4.5, which is still 2 over 1. So same thing. For the second part, B to A. So really it's just a reciprocal. We're flipping this stuff around. 10 over 20 is the same thing as 1/2. We could do 4.5 over the 9, and that's going to be also 1/2. All right, for the bottom one, simplify the ratio. We can't just do 36 over 9 and get 4. One's inches, one's feet. You have to be very, very careful with that. Ratios compare the same thing, so it's got to be the same units. So I'm going to convert the 36 inches into feet. So I'm looking at 3 feet to 9 feet. So as a fraction, it's going to be 3 over 9, which is 1/3. Now, I want you to answer this question. Let me get the whole thing there. Doesn't matter which units you convert to. Hit pause, try that on your own. I changed the inches to feet. What if you change the feet to inches? Does it matter? Go ahead, hit pause, try that out. Okay, the measures for this example problem says the measures of the angles of a triangle are in the extended ratio of 2 to 3 to 4. Find the measures of the angles. So, obviously the angles of the triangle are not going to be 2 degrees, 3 degrees, and 4 degrees, but they are a common ratio. So the idea is there is this other number that we would multiply each of these ratio numbers, the 2, 3, and the 4 by, to get the actual angle measurement, okay? If you compared 2x to 3x, you're getting 2 over 3 because those x's would cancel out. So this x is representing that common factor between all three angle measurements. So draw a triangle. One angle is going to be 2x, one's 3x, one is 4x. And as you all know, the three angles add up to be 180. And so here's how we're going to solve this problem. So we're going to have 9x equals the 180. X is 20, but that's not the answer to the question. It wants you to find the measures of the angles. So one angle is 2 times the 20, so we got 40 degrees. One angle is 3 times the 20, so that's a 60 degrees. And the last one is 4 times the 20, so that's 80 degrees, which 40 plus 60 plus 80 is the 180. So that works well, but that's the idea here. This is the key part. You have that common factor that is there between all those numbers, and so when you simplify that ratio, that common factor cancels out, giving you the ratio 2 to 3 or 3 to 4. Okay? Now, a proportion. All we've been talking about with the ratios is just the one fraction. Proportions are an equation where you have two ratios that are equal. So basically, you have a fraction equal to a fraction. And as it says here, to solve a proportion, you're going to cross multiply. Okay, it's actually called the cross product property, but cross multiplication is just how we talk about it. So the idea of a cross multiplication, you're going to take this denominator and multiply it by that numerator. You're going to take this numerator and denominator and multiply those together, and those answers are still going to be equal. So 24 times x, and that's actually going to be on this side. We multiply both sides by 24. That's going to be a 24x will equal, when we multiply both sides by the 27, we get 8 times 27. All right, now the question is to solve this. So we're going to try to solve for x. So we're going to have to divide by 24. Okay, I don't have a calculator with me right now. 8 times 27 is a number, so I'm going to answer this a little bit of a different way. 8 times 27, all right? 24 is 8 times 3. Common factors of 8 cancel out. Now I'm looking at 27 over 3, which is 9. There's the value of x. Okay, for this second example, same idea. We're going to cross multiply. So this times this, and then we're going to do this denominator times this numerator. So we would get 2 times 4x is 8x equal to, we would have x plus 3 times 5, which means we have to do some distributive property. So we get 5x plus 15 equal to the 8x, and now we're just solving for x. So subtract your 5x, 3x equals 15, x is 5. All right, that's the idea of solving proportions. They do get a little bit more difficult. You'll see that tomorrow. Excuse me. Okay, a different type of average. It's called the geometric mean. Now, you know what an average is. The average between 10 and 30, you take 10 plus 30, you divide by 2. So you get 20. The idea of our common definition of average is, if we started at 10, to get to 20, we had to add 10. Add 10 again, that puts us at the other number. So we started at 10, we had a 30, the average was the 20, okay? To go from the starting point to the average, you added 10. To go from the average to the end point, you added 10, okay? It's right in the middle. It's like a midpoint. That's the idea of average. This different type of average, called a geometric mean, I want you to think about this a little bit. So I've given you a couple of examples. All right, the geometric mean between 4 and 9 is 6. So, and the other example, geometric mean between 6 and 24, it is 12. Okay? The normal average, like we talked about up here, this is adding. Okay, you're adding the same thing. So the starting point to the average, you add the same number to go from the average to the end point. Okay, addition is our basic definition of average. The geometric mean, it's a different type of average. So we're not doing addition. So I want you to play around with these numbers. See what you can come up with. I'll give you the definition. You can start to see the definition over here, teasing you a little bit. I want you to play with those numbers, see what you can come up with. All right, I want you to go ahead, hit pause, and try this problem out. We'll talk about it in class on Monday, but I want you to just see what you got. This is a basic example of currency. It's a very common currency, or a very common occurrence that you have to deal with this kind of stuff. You know, we're an hour away from Canada. As a kid, I went to Canada all the time. I'm sure some of you do. For whatever reason, but we used to have a cottage there. So this is very relative to what can happen around us, and you got to think about these things. So hit pause. Please try to answer these questions, and have a good night. I'll see you in class tomorrow.